Good morning. Welcome to lesson 12-2, the parallel and perpendicular lines. We did explore parallel and perpendicular lines in our first unit of the year when we reviewed the basics of algebra. But in coordinate geometry, they play a very important role. So, slopes of parallel and perpendicular lines. We're going to be looking at everything about parallel and perpendicular in terms of their slope. So when lines are parallel, their slopes are the same. That means if a slope of one line is 1/2, the slope of the other line is also 1/2. Okay? And it means that they will never intersect. So when my lines are parallel, they never cross. So if you want to, you can draw a visual that basically says that these two lines are parallel because they're never going to cross. And when my lines are perpendicular, their slopes are negative reciprocals. You know who you are, but remember, you did have a little bit of a tantrum with this. So negative reciprocals are basically saying that if I have a slope of 2, my negative reciprocal would be actually 1/2. And I'm saying negative, so it would be negative 1/2. So it's basically saying that if you have a whole number, put it over 1, flip it, and then make it negative. If you have a fraction, so if my slope is, say, negative 1/3, it would actually be flip it, so 3 over 1, and the negative of negative is a positive. So it's basically saying that these two slopes are perpendicular to each other because they are negative reciprocals. This is the parallel symbol. This is the perpendicular symbol. It's basically an upside down T. Okay, so knowing the slope relationships of parallel and perpendicular lines helps us determine the equations of these line types quite easily. To generate the equation of a line, we need a slope and a point, and knowing that relationship is either parallel or perpendicular provides us more slope information. Slope actually also helps us describe other situations, so it basically tells us a lot about our function in terms of it increasing or decreasing. But we're not going to focus on the writing of the equations today. We're actually just going to focus on the slope aspect. So we're not going to really be writing the equation of a line today. Tomorrow, we'll be writing the equation of the perpendicular bisector, which is just a process that puts together your slope and your midpoint. So for each of the following, we're going to find the slope of the line parallel to this line and the slope of the line perpendicular to it. So for our first situation, we have y equals 4x minus 7. So when I look at this, the first thing we want to do is find our original slope. So our slope is always the number attached to our x, as long as it's in y equals mx plus b form. So I have to ask myself, is y equals 4x minus 7 and y equals mx plus b form? Yup, it is. So my slope of this equation is 4. My parallel slope is the exact same slope. So my parallel slope is also 4. My perpendicular slope, if I'm starting with 4 over 1, because anytime I have a whole number, it's really just over 1. 4 divided by 1 is 4, that's why I can write it. I flip it, and I negate it. So my perpendicular slope is negative 1/4. Let's go on to our next example. I want to find the slope of a line going through the points 0, 4, and 2, 0. Well, you know your slope formula is y2 minus y1 over x2 minus x1. So my second y is 0 minus 4 over 2 minus 0. 0 minus 4 is negative 4. 2 minus 0 is 2. Negative 4 divided by 2 is negative 2. So that's the slope of this line. If I want to find my parallel slope, I want you to ask yourself, is that going to be the same or is it going to be a negative reciprocal? You got it. It's the same. So my parallel slope is just going to be -2. My perpendicular slope I rewrite my -2, draw my arrow to basically show them flipping it. It's really -2/1. I'm going to flip it to make it 1/2, and the negative of a negative is just a positive. So my perpendicular slope is 1/2. And that's it. That's all you're doing. The most common situation, which you're going to see later on, is given the following pair of equations, determine if the lines are parallel, perpendicular, or neither. And then we just basically have to explain. We're not going to really explain. We're just going to verbally discuss it. That way we don't have to write as much. So I have y equals 2x minus 5 and y equals 1/2 x plus 7. I want to figure out if they're parallel, perpendicular, or neither. So the first thing I'm going to do is actually find the slope of each line. The slope of my top equation is the number attached to my x. It's not 2x. If you say 2x, imagine me screaming. My slope is just 2. My slope of my second equation is 1/2. So they're obviously not the same, so they can't be parallel. Are they perpendicular, though? So if they're perpendicular, this is really 2/1, so I would flip it, and it's a 1/2. So right now I'm thinking they're perpendicular. But if I wanted the perpendicular slope, this would be a -1/2. Is this 1/2 negative or positive right now? It's positive, so it can't be perpendicular. It is neither. That's your final answer. Now let's go on to our next example. My first equation is y equals -3x plus 1. My slope is -3. My second equation is 1/3. My slope is 1/3. So what I'm going to do is I'm going to say, are they parallel, perpendicular, or neither? So if my slopes are parallel, they're the exact same. So I have to ask you, is -3 equal to 1/3? Nope. So it can't be parallel. Now I have to ask myself, are they negative reciprocals? So I'm going to just rewrite -3 and put it over 1. I'm going to flip it. And the opposite of a negative is a positive. If you look up here, it did become a 1/3. So my lines are perpendicular to each other because they are negative reciprocals, my slopes. Now we're going into trickier territory. I have two lines that are not in slope-intercept form. So by putting in a line into slope-intercept form, it needs to be in y equals mx plus b. What I would like you to do, if you remember, try to put these two equations into y equals mx plus b form, and then see if you got them correct. If you forgot how to put an equation in y equals mx plus b form, follow along for the first one. I'll make this my black equation. So 3x plus y equals 8. I want to get y by itself, so I need to move everything on the left-hand side to the right-hand side. So I have a positive 3x. To get rid of a positive 3x, I subtract 3x from both sides. So subtract 3x, subtract 3x. My 3x's cancel, so I'm left with y equals -3x plus 8. The reason why it's -3x plus 8 is because the 3x and 8 are not like terms. And I always write my equation in standard forms, which means I have to put my x in front. I am now going to find my slope, and my slope is simply the number attached to my x. So it is a -3. Now I have -6x plus 2y equals 16. The only way to get rid of a -6x is to add 6x. So I get 2y equals 6x plus 16. Now the only thing I can do to get rid of that 2 is divide by 2. So I get y equals, because remember I have to divide everything by 2. 6 divided by 2 is 3, so I have 3x. And then 16 divided by 2 is 8. I'm going to box that equation. And my slope of this line is 3. Because 3 is attached to my x. So now when I compare these two equations, I have a slope of -3 and a slope of +3. Ugh. So I have to ask myself, are they parallel, perpendicular, or neither? Well, if they were parallel, both slopes would either be -3 or +3. They're not the same, so it can't be parallel. If they were perpendicular, they would be negative reciprocals. They are not negative reciprocals. So, in this case, it is neither. So, here's your next task. I would like you to complete the independent practice. If you are stuck, don't forget to make sure you write down your daily question or your noticing. If you have any questions, please email myself or Miss Kimmick. Have a great day.